All right, before we drop a little DeMauve on us, let's recap this week coming up. So today we're going to deal with DeMauve. Tomorrow we'll deal with roots. And Wednesday we'll finish off roots and also do some studying for Thursday's test. Okay? So test on Thursday of this week. Now, also up on the board up there, you see that we've got retakes. So if you are one of those people that would like to retake the 6.4 test, that's a 2-day process. Okay, that's we need to go over it first. Okay, and you need to go over it with me or Mrs. Hill. Okay, nobody else, just us two. Then you're going to need to study that. And then you're going to need to take it the next day. So a 2-day process, rather than wait until Friday, you should probably get that process started by Wednesday. Okay? Just in case something happens.
Does it matter if your grades during, like, if I have no cancel over with you?
Yep. Okay? Alright?
The homework bill, is it like...
It's going to be totally on your own this time. If you think that you need extra help, and you should by now know if you need extra help or not. Okay? It's one of those things. And then, so for both of those homeworks. Okay? Alright? It's the end of the third quarter. For some of you, it's the end of the third quarter of your senior year. You should be able to decide if you need extra help on something or extra practice on something and get that done prior to Thursday. Okay? And then Friday we need you to bring Chromebooks because we have to register you for NPC for the dual credit aspect of it. Even if you're not going to take it, we still need to register you for it. So that we got that going on. Okay? So lots of stuff going on. Again, the retakes, I would start that retake process by Wednesday at the latest. Okay? Give yourself some time to get that done because this week's going to be crazy because it's the end of the quarter. It's 5 days until spring break, and I'm sure you're going to have multiple tests in all of your classes this week. Okay? Or I should say in all of your classes, multiple ones, but you're going to have tests in all of your classes. Okay? So, plan accordingly. Okay? All right? So, let's talk DeMauve. DeMauve actually comes out of kind of logic, and we'll develop that logic here in a minute. So, if we were to do this one by hand, 2 minus 2i times the square root of 3 to the 5th power. If we were to do that by hand, what would we first have to do? Or what does this really mean? You're multiplying 5 of those exacts. 5 of those exacts, right? So we'd have to do 2 minus 2i times the square root of 3. Then that's 1. And then there's 2 of them. And there's 3 of them. And there's 4 of them. And there's the 5th one. Right? Okay? So how am I going to do that? How are we going to do that? How are we going to multiply 5 binomials together? Get back to algebra. Dylan.
You could do 2 raised to the 5th power minus 2i square root of 3 raised to the 5th power?
Nope. Can't do it that way. Because I missed all those middle terms.
Oh.
Yeah. Yep. That's what people want to do. And that'd be cool if we could. We can't do it that way. How am I going to do this? Right? Okay. So if I can I do more than 2 at a time? No. Can't do more than 2 at a time. Alright? So what does this become then? Just those first two. 2 times 2 is 4 plus minus 4I times the square root of 3 plus 12I squared. Yes? No? Maybe? Yes or no? 2 times 2 is 4. Do we agree with that? 2 times negative 2I squared roots of 3 is negative 4 squared I squared roots of 3, right? Right? So really this one here should be negative 8 I squared roots of 3. Because there's 2 of them, right? Okay? Negative 2I squared roots of 3 times negative 2I squared roots of 3. Negative 2 times negative 2. 4. I times I. I squared. Square root of 3 times the square root of 3. 3, right? Okay? So 4 times I squared times 3 is what? 12I squared. Alright? So we got that. Do I like that? So this really is what? I squared is negative 1, so this is really negative 12. So this is really negative 8 minus 8I times the square root of 3. Right? Now, the nice thing is that these two would also multiply together to be negative 8 minus 8I times the square root of 3. Right? And then that is going to still be multiplied by 2 minus 2I times the square root of 3. Now what do we have to do? Work the two blues? Okay, let's work the two blues. So negative 8 times negative 8 is positive 64. Negative 8I square roots of 3 times negative 8. Positive 64 I square roots of 3, right? But there's 2 of those. So that's going to be positive 128 I times the square root of 3. And then negative 8I square roots of 3 times negative 8I square roots of 3. Plus so that's really minus 192, right? Okay. So that, we'll go into this, into orange then. So that's going to be what? Negative 128. Yes? Got to close off my parenthesis side. Alright. So, I knew it was going to do it, and I still went for it. Alright. what's that? Negative 256? Plus 256 I times the square root of 3 plus 256 I times the square root of 3. Ooh. What do we got there? Minus right now. Oh, tap the brakes. This should have been minus right here. Ruh-roh. Right there, that should have been a minus. So how does that change things? Changes what? This first one, the minus, right? Okay. And then lastly, we have negative 2 times negative 128. Negative 2 times negative 128. 256. Square root of 3 times the square root of 3. 3. 256 times 3. How much? 768. And then that's I squared, right? I feel like we're missing something. This one should be, no, that's negative. Positive. I feel we're missing something. Is this an easy way to do this? No? Alright? So what do we get there? Negative, what's that, 1024? Yeah? Feels as if we did something wrong there. We're off somewhere. Minus there. Yep. We're off somewhere. Negative 128. Positive. What's up, Austin?
I think it should be negative 128 plus 128i.
Plus, oh yeah, right there, yeah, that should be plus 128i. Yep. Right here.
It wasn't.
Did they change it?
Yeah, I know, that needs to be negative.
Oh, okay. Alright. So then this should be so then they're both positives, right? So then that just changes this to be plus 512 I times the square root of 3. Still, does it make it easy? Still off by that first number. We're off by 256. Actually, we're off by a half. Positive, positive, then it becomes negative, less negative. Oh, because then this changes to negative. Right here. That right there changes to negative. Yep, there we go. Now we got it. Now I figured it out. So then this changes to 512. Now I get the answer I'm looking for. Okay? Easier way? Okay, let's try to find it. So my original problem was 2 minus 2I times the square root of 3 to the 5th power, right? What if I changed that complex number into trig form? Okay? If I did that, that would be, my R value would be 4, my angle would be 300 degrees. And that would still be to the 5th power, right? Right? Okay? Trust me on it, that's what it is. Okay? Alright? Now, if I'm multiplying a trig complex number, a trig form complex number, what do I do? But what do I do? What do I do when I'm multiplying two trig form complex numbers? Yep, exactly. Flip over and flip one more. It's in a big black box at the top of the page. So I multiply the R values together, and I add the cosines. Okay? So if I'm doing that 5 times, right? Because if I do 3 trig form numbers and I'm multiplying them together, I would multiply the 3R values and add the 3 theta values, right? If I do 4, I would multiply the 4R values and add the 4 thetas. If I do 5, I multiply the 5. So this would really be 4 times 4 times 4 times 4 times 4, right? Then times the cosine of 300 plus 300 plus 300 plus 300, that's 4, plus 300, plus I times the sine of the same thing, right? Right? Well, what's 4 times 4 times 4 times 4 times 4? What? It's 4 to the 5th, right? And what is 4 to the 5th? 1024. And this is like 5 times 300, right? Right? Okay. Do I like, in terms of trig, do I like 1500 degrees? No. What do I like instead? Less than 360, right? So I got to subtract off 360, right? So 1500 minus 360 is what? 1140 minus 360 is 780. Minus 360 is 420. Minus 360 is 60. Okay? So here, instead, I like 1024 times the cosine of 60 degrees plus I times the sine of 60 degrees. Now, you may be saying to yourself, oops, I guess I can't get them on there. Oh, maybe I can. Those aren't the same thing. Or are they? What's the cosine of 60 degrees? 1/2, which means this is 512 plus What's the sine of 60 degrees? Square root of 3 over 2. So that would be 512i times the square root of 3. And now, look what just happened. I think I can get him in there. Shabam. We end up getting the same thing. Okay? And that is actually what's called de Moivre's theorem. Okay? De Moivre's theorem is this thing right here. Any trig complex number to the nth power is equal to r to the n power. So I take the r value to the nth power. In this last case, we took 4 to the 5th power. And then for my thetas, I multiply theta by r, which is what we did in the last one. Okay? So we can go, as long as it's in trig form, it makes it a lot easier. No confusion, no nothing. It's just boom, there it is. Okay? Or whoop, there it is. You grew up in the 90s. Okay? So, in order to use de Moivre, what do we have to do? We got to put it in trig form first. Yeah? All right. So let's put this in trig form first. So my r value here is going to be negative 3 quantity squared plus 3 quantity squared, and I'm going to take the square root of it. Yes? Okay. So that's going to be the square root of 18, which is 3 square roots of 2. Yes? Okay. Theta prime, then, is going to be the inverse tangent of 3 over 3. That's going to be 45 degrees. Which quadrant am I in? Quadrant 2? So what is my actual theta value then? 135. So this is really 3 square roots of 2 times the cosine of 135 degrees plus I times the sine of 135 degrees to the 4th power. Okay? So now let's apply de Moivre. De Moivre says that I need to take my r value here, 3 square roots of 2, and take that to the 4th power. De Moivre then says I need to take my theta, 135 degrees, and multiply it by 4. Three square roots of 2 to the 4th power. 824? 324. 4 times 135. 540. Do I like the angle degree in trig form of 540? We can get it down to 180, right? So really, this is 324 times the cosine of 180 degrees plus I times the sine of 180 degrees. Yes? Okay? So, my question to you is, what would the standard form be then of that? Be what? Negative 324 plus 0i, right? Or just negative 324. Yes'm? You try that one. So you should have gotten an R value of 2 and a theta value of 60 degrees because it's in quadrant 1. Yes? Okay. Right. Now the question came up earlier. Do we have to, the question really was, Lint, do I have to do this next step? Well, I'll put in black, which was 2 times the cosine of 60 degrees plus I times the sine of 60 degrees, and take that to the 4th power. And the question was, that's kind of a U thing. You know what I mean? If you want to rewrite the problem in trig form, and that's fine. If you do, great. If you don't, great. You're still applying them off. You know what I mean? You have to do the green, because you got to get it in trig form in order to use them off. Okay? But if you want to rewrite the problem, that's totally up to you. Okay? So that's going to be 2 to the 4th power times the cosine of 4 times 60 plus I times the sine of 4 times 60. 2 to the 4th is 16, correct? So that would be 16 times the cosine of 240 degrees plus I times the sine of 240 degrees. Am I okay with the angle measure there? Yep, I'm okay with that angle measure. Or if I wanted to change it into standard form, what is the cosine at 240 degrees? Negative 1/2. So this would really be negative 8. What is the sine at 240 degrees? Negative root 3 over 2. So this would be minus 8i times the square root of 3. Now, looking ahead to Thursday, we're not going to ask for both, but we will ask for one. Sometimes we're going to ask for it in trig form. Sometimes we're going to ask for it in standard form. Okay? Either way, you should know how to go between the two forms. Okay? Questions, comments, concerns? Fantastic. I'm done.